Audio check, audio check. Test, audio check, audio check. Okay, we should be good. Alright, so, welcome to the stream. This stream will be working on XOS. If you want to check out the GitHub repo, it's down in the description, at least hopefully. So today, just a brief overview of what XOS is, since this is probably the first stream that you guys are seeing. I think I've done a few years ago. So, essentially, XOS is an operating system that I'm writing. The plan is to make it so easy that your grandma can use it, and support all three major operating systems natively. So you can take applications from Windows, Linux, or Mac OS X, drop them in, and they'll just work. And we're doing that through a process I'm calling live linking. We'll talk. You can go look at the PowerPoint down below for a little more explanation about XOS. Now today specifically, we have to finish the conversion to Multi-Boot 2 and Grub 2. Big thing there is I've gotten most of the groundwork laid out, but it seems to be interrupting and causing a fault whenever we try and use it. So we need to see what's going on in there and move on from there. So just a little bit of information more. I don't care, VS Code. So a little bit of the important stuff that we're going to be dealing with. I'm going to be over here in Multi-Boot. I'm cheating a little bit. So with Multi-Boot 2, in the spec they give you this nice long header with all the structures that you'll need. And over in Multi-Boot info.h, we've got a couple of functions, nothing real big, just a build and a get to get an individual tag. Over here we build out, and let's see, yeah, we build out the information that we need. We page in the multi-boot information structure. Then we go and reassign its address to its virtual address. Print that out. Make sure that it's properly aligned. Probably could use an assert here, but who cares? Read its size, which is the first element in the structure. MBI minus kernel start. Then we go and page in the entire MBI instead of just the starting size. And then we go through each tag and assign a starting point to the tag. assign that starting point. And there we go. And we've got our start. Actually, where is starts? Oh. Your void pointing is sitting up here that I didn't see. So, what we need to do is figure out what's causing our interrupt. So, it's definitely hitting down here because we're halting when we hit. And we're getting a 13, which should be a general protection fault. What I'm actually going to do is see if we can get a little more information out of this. By saying, see if we get number is not equal to 13. So all I'm doing is only halting on everything that's not, I don't have a format around here, that's not going to be interrupt 13, which is the first interrupt that we were seeing. So we're going to build that. I've just got a quick little script that will mount, copy the image, and to the flash drive that we're using, and unmount that flash drive. Just adding a couple verbose flags so that I can make sure that it's working. Yes, okay. So, right now I'm using a laptop because I haven't installed Box. Speaking of, I should get that installing. So, we'll get Box. So, we cause an interrupt, we get 13 and then a 14 right after, which would be a general protection fault followed by a seg fault. Which is not exactly what we wanted. Do I actually ever define return? I'm going to leave that there. I don't think I have that defined anymore, but we'll leave it there just in case. So since that wasn't tremendously helpful to me, let's try switching back and getting Box. See if you can see Box properly. Let's go desktop 7, Box. Let's go ahead and edit options. We're going to do a boot device. I think we can do 4 disk. No, we can't do that. Let's see. Let's go edit 12, 13, 3. That wasn't very helpful. Let's see. /dev/SDD, is that what we're on? Yeah, SDD. And let's start the debugger, maybe. Thank you. No bootable device. Interesting. Let's try this. 3, 12, 12, floppy, not floppy. 4, disk, /dev. Oh, I know why it's not working. Well, that didn't work. So, let's try. This is the first time I'm trying to use Box with a flat. Okay. So obviously I don't know what I'm doing. USB. Let's see if I can figure out how to use Box. Okay, so that's from 2012 saying that you can't boot. Okay, so Box isn't going to work for us. Which means we're going to have to do this the old-fashioned way. So we're going to go over to OSDev Wiki and grab us ourselves a general detection fault. And I wanted to bang in front of you. Yeah. Where is what I'm looking for? Fine, what? Oh, of course I don't have the... No, that's not what we want. Where the fuck is... No, it's not a segmentation fault, it's a page fault. Here. You have to even determine what went wrong. You can use the exception code. Okay. But the question is, where in the fuck is... That brings me back to here. That's not what we're looking for. Yeah. We know what that is. We know what that is. But what the hell? Page fault occurs? Yeah. Let's go look at our... Exceptions. Error code. On the top of the... Okay, here's what we're looking for. Finally found the page that we're looking for. So, page faults... Oh, I don't care about that. Okay. Page fault. The error code is formatted like this. Caused by writing 1 in a reserved field. When a U1 set page fault was caused by CPL3. What is it? Privilege violation. One set was caused by a page write, page read. Okay. So, what we're going to need to do is take... Actually, let's see what a general protection fault... Segment error executing a privileged, well, we're not CPL equals. Writing 1 in a reserved register field referencing or sets an error code, which is a segment selector. Otherwise 0. Okay. So, in theory, if we look at our wrapper, we push EAX, so we're going to pop into EBX, then we're going to push that, and then push EBX, then we're going to pop EAX, and we're going to push or pop EBX. So in theory, I should be able to take another uint32t error code. Well, no, that's not where the error code. Yes, code. Well, not necessarily. So what we're going to do is, who has an error code? On the top of the stack. So we've got a double fault, TSS, I actually think it has to do with what I'm paging in, but let's do this. Let's do this. Let's go ahead and Yeah, let's pop EBX. This may totally destroy my stack, but now we're going to push EBX. And then we're going to take the error code and print that. And we're going to do the same exact thing here, except we're going to take the error code. And let's build. And with any luck, this will give us the information that we want. Well, that's interesting. I got those backwards, which is fine. So, just for everybody's reference, we got 640 and then 13. So, we go decimal to binary. $640. We set those bits. So we've got 3, 6, 7 zeros. There's what we're looking for. 3, so somewhere in the index. Okay, so we're referencing the GDT, it looks like. Right, 1, 2, 3, 4, 5, 6, 7. So the 8th bit is a 1. What does our GDT look like? Well, first let's take and copy you. Okay. Paste you, grab you, drop you over here. So that we can see both exceptions this time. Hopefully. This is the trouble with operating systems. You come and you break fucking everything. It would appear that we don't actually get any page faults anymore. It looks like it's 13 and 640. 640. Which means something's wrong when I build my GDT. Which looks disgusting, but let's see. Let's print out let's do this. Right. got printf in here, so let's do GDT 0%. I think %d is what we're using. Let me double check this. Percent, yeah. And D, yeah, right int. Okay, %d. And we'll do underscore GDT 0. And that should... Don't forget your semicolon and to include printf. Should be utils slash printf/printf.h. Also hopes to have the flash drive plugged in. Oh, it moved to C. Okay. I could probably use QEMU for this. So let's see. As QEMU. There's that. Well, that ain't helpful. It scrolls off the screen. So let's put in an ASM. Hit breakpoint, halt, halt. Okay, that'll work. Well, let's see. Can we get QEMU dash system /dev SDC? Haha, we can. So I don't know the key to break out of QEMU. So I'm gonna have to do that on my phone. QEMU really mouse. Left control, left alt. Control alt G. There we go. There we go. Okay. So quit box. We're gonna now use QEMU. And I think I got my Okay. So here we go. Fully boot and then we just totally blow up. Did I build this with the breakpoint in there? I don't know. Well, that ain't particularly helpful. what I really wish is I had Box to inspect the GDT, but Box is being a little bitch. Or can I? Let's look at something. So, we're going to have to do this by hand. And I needed that number. Let's bring that over to desktop 7. 29535723670. No, 0. Okay. Now there's our 32-bit number. And if we look at, and I can pull that up, let's go over to bring that back to 4. Bang OSDev, GDT. Oh, I don't need the tutorial, I need that one. Alright, here's our wonderful structure. So, limit. Honestly, this would probably be easier in hex. Decimal to hex. Thank you. Drop you in. So we've got F. So we've got B00 BF 00F. So our limit is 0F. Base is F0. This doesn't look right. That's our next base. There's our access. There's our limit. Okay. So limit. That's lim base. Base access. Limit flags. And base. So base is B, B, F0. That definitely don't look right. But yet, I have yet to change anything in the GDT. This is an easy way around seeing if I did something wrong. We build it, but we don't load it. And we need to get rid of that breakpoint. No. It's not the window that I wanted. So we're gonna build, and we'll drop in there. Huh? Well, that's not helpful. Somehow we're triple faulting now. I thought we were going forward. Okay. I am going to be right back. I'm going to grab my floppy drive and see if we can get Box to work that way. What was that?
Do you have any activity?
No. So let's go over to Box. Interesting. So it works in one window but not the other. Okay, fine. Let's... Hello. No bootable device. Okay, what the fuck? Box. Sudo box. Added option. okay. Floppy is SDD. 12. 1. 3.5 yet. Dev slash SDD. Okay. So while we get that to boot, let's go command line. Actually, let's go edit root kernel. I don't think grub legacy supports multi-boot 2. Legacy multi-boot 2. Yeah, here's the page for grub legacy. Yeah. Yeah. That doesn't help me. Because I need multi-boot 2 support. Na. I already over grub. Let's go over to box. Yeah, I don't. Okay, so we're gonna do this even more differently. So when we build the global descriptor table, we're going to the limit GDT entry 0. Let's go over to the GDT tutorial. So I need to remember, I think you're supposed to put a null entry first, and then a flat setup. 00000F 092, and I don't really care about that. So, and I don't care about ubox. We're going to use QEMU anyway. So we need 0, 0, 9A CF, 9A flags. What flags are they using? Do 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 do. Where is what I'm looking for? Okay, flags, GR, 4K, don't really care. Size bit 0, protected, 32 protected. So we want bit 7. We want those two bits to be 1s and those to be 0s. So really what we want is to do this. Flags int equals 0b 1100. The access byte is 9A and 92. That's not the da-da-da-da-da. Sure. Binary is 1100. That was so why is flags got an extra F at the end of it? Because when I pass the flags, flags union, flags S equals flags, flags I bit shift 4, is it 00, and then so the limit is that. That should work. I honestly don't know how that got changed. So let's try that. And we're still broken. Why are we still broken? Let's go ahead and leave the CF. Just set those to 0. Do one thing at a time. Speaking of which, when did those change? I don't want master, I want switch to grub to memory structures, global descriptor table, blame, fix bug causing triple fault. Okay, sure. Okay. Yeah, that should definitely be 0. Then we load it. So I want to print F the size percent d. Actually, we're going to do that in hex. I think we can do that with our printf. Yeah, base 16, yeah. Okay, so we can do percent %x, location is percent %x with gdtd dot size, gdtd dot location, drop in a semicolon, breakpoint, and pound include util slash printf. And let's see where we are. Why didn't I hit a breakpoint? Did I comment that out? No. It's becoming very apparent that I'm not actually loading a GDT. Now the question is, why? I have to add more breakpoints. Preparing GDT, okay. So we can prepare the GDT. So now do we come, obviously we come after the GDT loads. So, what the fuck is happening? I don't get. Oh, I forgot to put a breakpoint in. Okay. So load size is 17. How is the load size 17? A size. Paging does apply. Good. I was about to check that. If I said size. If I remove the breakpoint here and here and built. Okay, I swear something's going on with QEMU. Because I don't even have breakpoints there. So let's try this in real hardware. Right, it should say, it should print the size and location, and then it should come back to the kernel, print done, and hit a breakpoint. But it doesn't. Let's remove that breakpoint. Is it like optimizing it? Let's clean it. Let's build it from scratch again. Okay, so no breakpoints means no breakpoints. One breakpoint, build kernel.cpp. So we should hit a breakpoint. Yes. Load size is not 17. And that seems way too high of an address. Oh, wait. The size of a GDT entry times size. Let's go back to 640. 1, 2, 3, 4, 5, 6, 7. And let's look at what our exception says. So index, so we've got external, which is not true. Table is 0, which is yes. So bit 1, then 2. I really need to figure out which tab I'm on. Okay. Then we go pull those off. Why is it trying to hit segment 50? Let me look at what assembly they've got here to load. The linear address should be computed as from flat. Okay, so move EAX. So then that. Set GDT with GDT. So EAX is the GDT. To move the GDT address to we're gonna go GDT to EAX. GDTR plus 2. Okay, so the offset. Move EAX. Stack pointer plus 8. Okay, so the size of the GDT. Size of an array. Found here. Yes. What is the jump? So let's try. Probably what's happening is Multi-Boot 2 doesn't preload a GDT for you anymore. Let me check the okay, machine state must contain the magic number, must contain the information structure, must be a 32-bit read-execute code segment with an offset of 0 and a limit of this. The exact value is that. Must be enabled, must be cleared. So let's do this. Let's do exactly what they suggest. I don't need a wrap. Okay, that wasn't what I wanted to do. Build. Oh, save and build. Inline assembly. Let me just look at what I use for this. So it's percent $. Okay. Here. Should be $, and then it should be comma comma. I don't know that. Assembly. Yeah. I don't. Okay. ASM. Percent 20, percent 10. Yeah, $, yeah. Colon. So you do colon output, colon input, colon clobbered. So output, input, clobbered is percent AX. Speaking of which, I need to add percents to all of that. Expected string literal before move. You literally have a string literal there. Unless those are the wrong quotes. What? Okay. So let's do this. I'm gonna pop. Which one of these? This one. To that screen, and we're gonna take this. We're gonna say mov percent AX 0x10 semicolon. Mov percent DS percent AX. No. Mov percent ES percent AX. Mov percent FS percent AX. Mov percent GS percent AX. Mov percent SS percent AX. So it does not like them being on different lines. Let's try this. Is it, what is it for inline? Oh, it's percent percent. Then clobbered registers get 1%. Bad register name FD. That really what it said? No, FS. Too many memory references. And should be $sign because it's a what? So let's add a new file called load.s. Drop that in and just do complete flush and .glob. No, what is it? That's the right operator. .global complete underscore gdt flush. And then we call complete gdt flush. And then we say there's this extern. Let me double check how I grabbed this correctly. Extern void pointer. GDT complete GDT flush. Helps if you have a semicolon. Void. Oh, it's a function pointer. So it would be void paren pointer paren. That should let me call it. Probably because I don't actually compile that. Let me check my make file here, not the old one. Except this is now load source memory jers. I spell wrong? Source, MEMORYSTRUCTURES. That should fix it. Cannot open. Copy relative path. No file or directory. Too many references for MOV. That should be %, %, %, %, %, %, $. Okay, so we've got a kernel.bin make clean build. I need to start handling headers eventually. Drag you back over here. You're going to go to desktop 4, desktop 7. You're going to control C. You're going to get built. You're going to run. Well, that's interesting. So let's read about what I'm actually doing. At 10, 1, 2, 3, 4. 1 is data. x86 ring level. I forget which register. Protection ring, where is oh Lord. There. Yeah. Okay, I don't get what the hell's going on. But I definitely made it worse doing that. Make. So we're going to get rid of that. I don't think I actually do that. I think that's supposed to be that. Let's see if we can get QEMU to cooperate. Okay, so we got the done. So let's go over to kernel.cpp and get rid of this breakpoint. Did I build it? No. Oop. Oh, I'm missing a paren. Okay. So we booted. And now we still triple fault. So how can we be triple faulting if we're getting interrupts? Let's not read that interrupt number. Okay, let's see here. Let's remove that. Let's not push EBX. Let's not pop. And if we do that, then we need to go over to our interrupt handler and get rid of the extra parameter that we've added. And get rid of our error code. And let's see, do we triple fault anymore? Yes. Okay. So what's modified? Get stat. Other than that, which, hell, I don't even have a reference to it anymore. So let's rebuild the bundle, make clean, and build it. And let's see where we are. Okay. 13. Really wish I had box working right about now, because I could actually inspect the GDT let's try and build so let's just run random commands we find on the internet. Format not specified. And let's see. What the hell? Not that. No, let's go, let's run grub-mk image help. Oh. Dash, oh, I'll put that all the way up here. I3 i386-PC. Okay, so ls temp tmp ls tmp gd tmp try slash core.img. I meant to say slash mnt2. No. Why, oh why do you do this to me, Grub? It's not even Grub, ZSH. Okay, so we've got an image. Okay. Oh, okay. Nano menu.lst. LST. CP star. Dev stdt slash mnt2. No. Right, I spelt it wrong. They will mount it. And actually we won't do that. Well, you mount grab myself another blank floppy. Drop it in. I'm gonna need more floppies soon. Okay. It's reading, it should have nothing on it. Yep. Copy star to Okay. So what you say is copy these files to a disk image, pop it in an emulator, and you're done. Okay. Your box. Edit 12.1 / dev / sdd. Oh. 3.5 inch 1.44 / dev / sdd. 1.44 meg. No. Right. 3.12.1 dev / sdd. No, it's 3.5 inch 1.44 meg / dev / sdd. 1.44 meg. Inserted. Okay, we're reading the floppy. God damn. Okay. Take 453. So what we're going to do is say grub -install. Let me see if I can trim down install modules. Let's see if I remember my options. I don't. Root. Right. Okay, so it's still mounted. So there, root equal root dash directory equals slash that. Check slash force slash dev slash sdd. Oh, I fucked up. I meant to add dash dash install modules. SSH multi-boot. Let me check something. Man. Grub. Install. Okay, but is it comma separate? What? Info. Okay, so it looks like it should be separated by white space, multi-boot, BIOS disk, FAT, SH multi-boot, BIOS disk, there. Whoopsies! Oh. Allow floppy. Grub, why won't... That really doesn't help me. I'm gonna try quoting that string. Okay, let's see if this will actually install. Damn it! Why can't I do this? Okay, let's go bring you back to 4. Get rid of you. What BIOS am I? Okay. So let's go ahead and box. Let's cd tilde workspace XOS ls cat bot.box. Actually, I want last. Sorry, see. Okay. So where are we? What VGA BIOS? Feedback. VGA BIOS. USB boot. Download. Okay, let's try this. Pacman-s C BIOS. Oh, C BIOS is already installed. So let's go arch pkg c. So where does it install things? Okay. Cool. So, work with box. What version of box? 269, that's bigger than that. And what version of CBox? Bigger than that. Okay. Nanos.box RC. Just get rid of that line. Actually, no. rm.box RC. Okay. Box. Let's edit the config. Actually, no. Let's save the config to .box RC 7 nano.box RC. Okay. US. Do I have USB UHCI somewhere? Alright, first of all, we need the magic breakpoints enabled. SDC. Right. LSBLK. Yes, SDC is our flash drive. Make sure we've got PCI enabled. PCI enabled. Okay, then let's start box. Let's begin the simulation. 1F12. Edit options 12, 15. disk. Where is net? That should give me enough time. God damn. Yeah, I know how to do that. What if I do this? 3, 12, 15, 15, 1, none. Network. Box. Open boot menu. Need like a delay for the boot menu, and it's not. Oh, I know what I can do. Edit 12 1 3.5 inch 1.44 meg slash inch 1.44 meg slash dev slash sdd 1.44 meg inserted F12. Okay, let's get one that I can boot off of so I get more time waiting for the boot menu. Inserted. Save.boxrc, yes. 12. No! Nano dot box RC. What if I just take off that? Why? Box can't open boot menu. Okay, I'm gonna take this guy's config. Actually, let me check something. Okay, so he's got boxlist cbios, box bios cbios 17 out bin. That could be why. Because I'm not using cbios. What? Okay, VGA, CPU, count 1, instructions per second, quantum, reset on triple fault is should be 0. Memory, magic breakpoint enabled is 1. Okay, let's try this. Ooh. Oh, yeah. I fucked up. Should be /user share. I have no idea what it's doing right now. 0 idea. So let's do this. Let's go nano box RC2, no. Except replace that with Oh, what the shit? Okay, paste that. Come up. Get rid of all that. Slash. That. And where's my VGA? From. VGA BIOS is that. Box read dot box RC2. Could not look up environment variable die. Oh. Slash dev slash SDC. Do dot box RC2. Oh, floppy A should be slash dev slash SDD. RC2. PCI is somewhere over here. I know, I just saw it. There's PCI. Let's go dot box RC2. What the fuck? Okay, so it looks like it's doing something. Am I running this with sudo? Yeah. Aha! Oh. think what I'm gonna do is call it here. Try and figure out what the hell is going on. With this and see if we can get anywhere. So I'm gonna go, and hopefully I'll be back tomorrow with a working emulator.